All right, everyone, welcome to the Utah Microservices Meetup Thursday, August 24, 2023. We will get to, let's just jump into the topic of the presentation. Let's do it. Okay, let me introduce our speaker here. His name's Antoine. And Antoine, let me do my best here. Leclerc is a software developer who primarily works with Ruby and the Eventide toolkit to build web applications, invented applications, and distributed systems. His approach to software development is rooted in the science of software design, software testing, and software product development process fundamentals, which he leverages to pursue root causes and preserve continuity. Among his professional experiences, he has led mission-critical technical projects, spearheaded cross-team communication efforts at a 100-plus developers organization, and co-authored an open-source research project on background job processors. When he's not thinking about software, you may find Antoine on a tennis court, a mountain bike, a kite surfing board, or in his house in front of an AC event, trying to survive the Texas summer. And the topic for tonight is controls. With that, Antoine, we turn the time over to you.
Thank you. And it is really hot here. My AC is actually not working well because when they replaced it, they put something too big. And so it freezes up on me. And today is one of those days. So I'm pretty hot, but we'll make do. I don't think I can share right now, my screen. It says it's disabled. Sure
is. Advanced sharing options. All participants can share. You should be able to now.
All right. Cool. Let me put stuff that I have in my background.
I'll cut that part out in post-prod.
All right. Can you see my cursor, by the way?
Yes.
Sorry, I did not hear.
Yes, we can.
Cool. Okay. All right. Controls. So I first came into contact with controls maybe 5 years ago or 4 years ago through the Eventide Project and through Scott Bauer in particular. And since then, really, I think software controls have been part of my software development work day to day. I would never trade them for anything nowadays. I don't think I could do any software development work without controls. And so this presentation is going to be an introduction to controls. And for those who already are aware of controls and know controls, I think it can maybe hopefully you learn something. You'll shed some light on some aspect that maybe is not obvious, but it's definitely geared towards people getting introduced to controls, and it's an introductory overview. All right, so first we'll go over the scientific method. I'll go over the scientific method at a high level, which will then lead me to talk about software controls. And then we'll talk about software controls in the context of automated and interactive testing. Then we'll dig into controls design, how they are designed, and what kind of design is desirable for controls. And then if it's done well and designed well, it'll lead us to talk about exemplars. And finally, I'll close off on by talking about the common misconceptions that newcomers may face when they start working with controls. So first, just to introduce, these are 3 definitions of engineering sourced from Merriam-Webster, Wikipedia, and the Oxford Dictionary. And the thing that I'm focusing on here is that in order to do engineering, we need to apply science. Basically, that's the common theme across those definitions. And so if we strive to incorporate engineering in our software development work, then we have to take a look at science and the scientific method. This is a high-level diagram sourced from Wikipedia that kind of describes the scientific method. The first phase usually is an observation question phase, which then leads to some research that needs to be done about a topic area. And then from that research, we can start forming hypotheses that we then would test using experiments, which would lead us to gathering empirical data from those experiments that we can then analyze in order to form conclusions or even just to inform further formation of hypotheses. So I want to take a look at two steps in there, the hypothesis and the test with experiment part, and put that in particular in, like, look at that through the lens of software development and how that applies to software development. So when we're writing software and when we're writing an implementation, we are implicitly or consciously forming hypotheses about our implementation, that it implements the functionality and that it works, that there are no defects. And then when we write tests or we perform tests, we are effectively performing experiments. And basically, an experiment in software development would look like, given some environment, some setup that we would try to control, exercising the implementation would lead to some output, to some side effect. And so speaking about the design of experiment, where we have control variables, independent variables, and dependent variables, if we map those out to an experiment in software, a typical experiment in software, the control variables would be the environment and the setup that you may have, for example, like in a test setup. The independent variable would be the implementation, and then the dependent variables would be what happens from exercising the implementation. All right, so software controls, what are they? Basically, it's software that we're gonna try, that we're gonna use in order to control the variables so that we can carry out experiments predictably. And when we start talking about control, it's important to know at which level we want to control for the experiment that we're carrying out. And this is where, like, a fundamental thing is that we want to try and control at the level of observation. For example, if we are testing something in the UI, for example, if you take an e-commerce website, and you have a product page, right, with at least products, and you want to add one to your cart. And so one of the experiments is like, when I click on add to my cart this product, then I will go to my cart. Then in that cart, I will see the product. I will see information about the product, etc. One could, in order to perform that test, that experiment, one could log into the database and, literally write some database language, some SQL, for example, to put a product in the database. But what we're saying with control at the level of observation is that if I'm going to test something in the UI, I should be able to set up in the UI using controls. So in the example I gave, it would mean that we could create a product through the UI and then leverage that in order to perform our test. There are two types of software controls, two main types. Programmatic controls, which is the kind of stuff that you would use programmatically, like in your automated tests, for example. And then there are interactive controls. There are a variety of interactive controls. You could have a control that you have to exercise at the command line, for example, in your terminal, and that would prompt you for input, for example. That would be an interactive control. And then you have higher level controls, such as UI controls, which are controls that you would have in your UI. And something that's really important is that those controls, when designed well, they benefit everybody, not just the developers. And anybody can take advantage of them, and that's more apparent when we start having controls in the UI in particular, for example. All right, now let's talk about testing and software controls, how software controls can be useful for testing. And for this part of the presentation, I have leveraged the account component, which is an Eventide example, part of the Eventide examples. And so one thing to note is that when it comes to testing, the test implementations in the account component are not our state-of-the-art testing, but they will be updated in Gen 3 of Eventide. So first, let's look at automated tests. So let's take part of the implementation of the account component. We have on the left the open command. It has 3 attributes: an account ID, a customer ID, a time. And then on the right, we have the handler for that open command. And so that handler implementation is pretty straightforward. It gets the account entity from the store. Then it checks whether the account is open. If it is not open, then it gets the clock time in ISO 8601 format. And then on line 34, basically the opened event is instantiated with the open command attributes, along other things. That's what the follow method does, among other things, metadata. And then the clock time is set as a process time on the open event. And then the open event is returned to the stream, the account stream. So here's a test. This is not what you'll find in the account component. I modified this test. This is the test that actually could be considered the experiment that is looking to confirm that the implementation of the open command handler, when actuated under certain conditions, it will have the output will be that the opened event is actually returned to the account stream. In order to do that, in this test setup, as you can see, we need a process time. So we get the current time. And then we need an account ID that we're going to assign for, sorry, I kind of jumped ahead here. So the first here, this time, is actually used to configure the handler clock dependency, which is then used, as you saw, here, right here. Then you set the process time. And so the other thing is that we need an open command, and we need to set the attributes on that open command so that then we can pass it to the handler on line 23. And so we get a random UUID for the account ID. We set that on the open command. Same thing for the customer ID. And then we get the effective time. We transform it into ISO 8601, and then we assign it to the open command. All right, so are we in control in this test? Would be like one question to ask. And can we be in more control? So one thing is that every time we're going to run that test, we're going to have different inputs, right? We're going to have different values for the process time, for the account ID, for the customer ID, for the effective time. And so that will increase variation across our test run, and it will reduce predictability. So one thing that we probably want to look to do in this instance would be to remove that variation unless it's absolutely essential to the test. And so if it's essential to the test, then it should be in the test. But in this case, it's actually superfluous. It's not needed, and it harms the experiment. So here's another implementation. This is not what's in the account component either in the implementation. I modified that one for the purposes of the presentation. And so we have now a hard-coded time. We have a string that is a representation of a UUID. The first part ends in 1 for the account ID. And then we have the same thing for the customer ID, except that the first part of the UUID ends in 11. And then we have a different hard-coded time for the effective time. Are we in control in this case? I think we're in more control, right? Because now every time we run the test, we have the same inputs. It's more predictable. It's a better test. But it's important to think about tests as a piece of your implementation. So tests it's code that we write, it's code that we maintain, and it's code that we run. It is different from the operational implementation, because it's not used the same way, but it is still code that you have to maintain and that will benefit from software design and this code will feel design pressures. There will be design pressures that will push towards some design of the test and the test setup in particular. And these tests usually sit on the edge, right? They're on the edge. They don't have anything that couples to them, but they couple to things. So they produce a lot of efferent coupling, and they usually don't have any afferent coupling. And so tests can benefit from things like encapsulation and abstraction and the dry principle, right? Like what's going to happen, you see on line 13, where I have the account ID. Once I need an account ID in another test, I'm going to have to copy that value over or introduce some variation between two tests, which then we need to be examined and we need to be justified as useful, necessary variation, essential variation. Otherwise, it's unnecessary variation. It should be eliminated.
Sorry to interrupt you.
Yeah.
For the benefit of folks who may be watching this later, you use the terms afferent and efferent coupling. Would you mind saying what those mean?
Yeah, so afferent coupling is things that couple, like if you take a thing, then if that thing has afferent coupling, it means that other things depend on the thing, right? They're coupled, so they use it. Efferent coupling is the counterpart. Other things have efferent coupling to that thing that's afferent. I don't know, without diagrams, it's a little hard to explain, but I hope that made sense.
So concrete example, if you write an Eventide component, you have an efferent coupling to Eventide, and Eventide receives an afferent coupling from your project.
Exactly.
So it's based on affects versus affected by.
Indeed.
Okay.
All right. So I think so we can do better with this test, and that takes us actually to the implementation that's in the account component. So if we leverage encapsulation, abstraction, right, then we have a controls interface that is created, and then the tests in this test setup can couple to that controls interface. And now if we need a process time in another test, or if we need an example command in another test, then we can couple to those control interfaces. The other thing is that we are now closer to operating, to have an experiment that controls at the level of observation. Right? What we want to observe is that an opened event is written with the attributes, with its attributes containing the values from the clock and the values that are on the open command. And so ignore like this part, the or fail, that's also outdated and that'll be updated in Gen 3. But if we look at the test redacted and we look at the assertions and the tests and the test names and the context and the other test names, then we're closer to this control at the level of observation. So this is kind of a summary of what we just talked about. You can see what we ended up changing from like the second version to what's actually in the account component. And we did all this by leveraging the encapsulation, abstraction, considering coupling, and controlling at the level of observation. All right, now let's look at an interactive test. So we have a control here on line 3 that we can leverage for an interactive test. And that interactive test is basically if I have the server running and I write the deposit command, then I will have a deposited command event that will be written to the account stream. So if I actually run that file, I will be able to see pre-printed the message I will see the log output from the writer. That indicates that the deposit command was written using the control. And then I can look at the attributes of the message that is printed, such as the amount, for example, or the time. And then if I look at my component that is running, I can see the output from the component. And I can see that right here, the deposited event was written. And then one additional thing that could be done as part of this interactive test would be to check whether we have the message in MessageDB by printing the messages and then looking at the attributes. So in an interactive test, the human is crucial, right? The human is in the loop. The human is an integral part of the test. Like you have to have eyes on, and you have to be looking at it and inferring. All right, so the next thing I think that would be useful to go over is the design of controls. And for that, we can also look at the account component. And those are all of the controls in the account component. We have controls for commands, we have controls for events, we have controls for writing commands, we have controls for the account entity, for the customer, for ID, time, etc. One thing that can be challenging when you're new to controls and you don't have much experience with them would be to know when to actually introduce a control. I think that a useful thing to think about is pulling the controls, like pulling the existence. I think I'll go over this. If you have a test and you're writing a test and you start feeling like you could have a control there, then you can pull the control into existence at this moment. So it would mean implementing the control when you feel the need for it, basically. And that's what I mean by pulled into existence. And I think it's good to look at for those signals and then implementing your controls then. With more experience, you start knowing when you're probably going to need controls and when you may want to implement them. For example, if you're writing an Eventide component and you just implemented a command in your Eventide component, the schema for a command, then personally, I would usually go and implement a control for that command in order to then actuate that control in IRB and see that everything's in order. All right, so I want to go over the design of the controls that were mentioned in the example with the automated test. So first, let's look at the process time control. So here's the implementation. The beginning is redacted, but we have the account component module. Then we have a controls module, a time module, process module, a raw module, and then we have an example static method on the module. Right, so this is usually how controls will be implemented. And then you can see that, for example, one benefit of having these controls is that we can have an offset milliseconds for the processed time and a different offset millisecond for the effective time, which are right here and right here. Now let's look at the open command control. So this is the implementation. It's pretty straightforward. We have a controls module, commands module, open module. We have an example sec method on the open module, and then we have the open command, which is instantiated, and then we assign each attribute by leveraging other controls. So, for example, if we take a look at the account ID and the customer ID controls, those are controls, and so the open command depends on those controls. And so when we're talking about controls design, we need to think about those things like what depends on what. Is the direction of dependency the right one? Are we coupled to things that will change this. I will couple to things that are more general, right? And so in this case, yes, like it would be outrageous if it were the other way around and we had the account, for example, control that depended on the open command. So if we take a look at the implementation of account.id, for example, in the control, very straightforward implementation, it actually depends on an ID control. And what it does is it actuates the ID control with the example method, and then it passes in an ID increment. For the customer ID, same thing, and it passes in a different ID increment. And the ID control itself depends on the identifier UUID control. And that leads us to exemplars. If the design of the controls in a package, for example, is good enough, then those controls can be exemplary. And so what we mean by exemplars is an average canonical representation of some object or a typical way to cause some side effect in the system. That's a pretty high level definition, but what does it mean? For example, in the account component, it means that if our controls can be considered exemplary, then we can package them. And if we package them, then they can serve as exemplars for other packages or for other people. So if I'm working on something that depends on the account component, then when I install the account component package, I can actually leverage the controls. If I want to look at the open command, I would do so. I could do so like shown right here in IRB, and I could see an example open command. The account component itself leverages exemplars from identifier UUID. It depends on identifier UUID, and it also leverages its controls. And the way it does that is by assigning the control of interest to its own control. And then the internal ID control, internal to the account component, can be leveraged in the other control implementations. The thing on the left, that's called an egress. And an egress is an internal interface that will serve as a proxy to an external interface. Now, exemplars are not only useful for package controls. They're going to be useful for at any level in the system. And so if we design our controls well, that we have control at every level in the system that we can leverage, then we're enabling capabilities like final inspection, sales demos, user testing, customer validation. So exemplars go beyond than just having exemplary programmatic controls. Now, the common misconceptions that newcomers to controls may face. One of them is controls are only for testing. And usually what's meant is automated unit testing. I hope it's been clear throughout this presentation. I tried to show how that's not the case. And we saw that, we saw that with an interactive test. We saw that with the fact that controls can be used as exemplars, which then enable things like final inspection, sales demos, user testing, customer validation. That's another misconception, as if controls are kind of like their own thing, and they are not subject to the same software design pressures as the operational implementation, for example. No, controls, when done well, you want to package them and they'll be part of your package. They'll be things that anyone can use. So they're definitely subject to software design. This one is a tough one to kind of try to assimilate, but I think the only thing that I would say for this one is, first of all, make sure that your trying to trying to observe at the right level, and then try to control at the same level, basically. And I think like the best way to learn that will probably be to expose yourself and to see good examples. And I think the Eventide examples are good for that. This one is a common one that I've noticed in myself when I started with control, and that I've noticed in other newcomers to control. Pulling a control in an automated test, for example, in order to mutate it right after, is not a good thing. Like if we're trying to control a value, we should push that value in the control and use the control interface in order to do that. This one is really common and can be confusing at first. I'll see a lot of newcomers want to put real values in the controls rather than just examples. And you know, examples, when done well, can be exemplars, which has our average representations, right? And by real values, I mean that people may want to put values that they have in their production database, for example, in controls. But what we should strive to do is put exemplary values, values that don't look like, they're not specialized, they're average, they don't matter. And if there is a value that is specifically coupled to and changes the system's behavior, then that's when you would use a real value in a control, a real value, a specialized value in a control. It would be clearly connoted through the interface of the controls. I think this one is obvious by now, but yeah, controls extend beyond just programmatic controls. We have UI controls, as I said, interactive controls. And Casey already is actually gonna tentatively do a presentation on UI controls next month. So we can look forward to that. And this one is a little on the nose, but it's worth mentioning. It's, you know, controls are not this special thing that we kind of do whatever with. When done right, we can have other people use them. So we want to make sure that the user experience with those controls is good, just like with your operational implementation. That's about it. If you want to view the slides, you can use your phone, take a picture, or click the link thanks to the QR code. There's also this bit.ly link that you can use to access the slides. It'll be a PDF. So I think there are like a couple slides where the animations are not, you're not going to have animations, so they may not render great, but like most of it will be perfectly legible. Thank you.
Awesome. Good job, dude. Yeah.
Questions, comments?
There was a slide with a command line that showed a selected row from MessageDB. And that was appealing to me. We have been...
do you want to see? Yeah.
Yeah.
There was the interactive test, this one. Is that it?
Yeah. Your MD print messages. Can you show more than that's behind that, or is that something you cannot share?
It's something that comes with MessageDB, I believe.
Oh,
right. Yeah. So it's with the Eventide toolkit. Yeah.
It's just part of the MessageDB Ruby package.
okay. I have been overlooking that. Okay. That was a rather obscure question. I hope it didn't derail anyone's bigger questions.
One question that I've had with controls is in the example that you showed, the various attributes of, say, a message. It would be like instantiate the instance of the thing you're making the control of. And then you set one of the attributes equal to another method that's on the control module. rather than inlining that within the body of the constructor. How do you know when to make it another method in the module, like a self dot precision offset or a time offset milliseconds, versus just putting that same value in the control constructor method?
Let me see. Okay, if I understand correctly. Oh, right. I think I need to share my entire screen for that. Let me see if I can fold. Oh, whatever. Let's just. Okay. Have the zoom controls in my way. So it would be like here, for example.
In the controls.
Oh no, in the controls. Sorry, my bad. Like here.
Yeah, on the right there. So ID increment is a separate method on the account component controls customer module versus just being inlined in the body.
It could be to verify that it's an ID increment because it's important. For example, in this case, I'm pretty sure that's why it's done that way. Are you saying like putting 111 right here?
Yeah, or in sometimes when you do a control, you have to instantiate, say, a message object,
Mm-hmm.
and then
Oh, and then you would inline like as opposed to using methods. That'll depend. It's like a pretty subtle nuanced thing, and that'll totally depend on your use case and whether you need to access those, whether it's important enough to separate it into their own methods or not. Like that'll depend. Yeah.
Well, what is this, what is this control made of? Like you gotta be able to answer that question. It's not a programming problem. It's a communication problem. What is this control made of? What are the significant facts of this control? The silence tells me that many people would probably inline this, which is basically how you program when you're trying to finish your day rather than programming to try to communicate your intent, which is one side is on the way down of productivity and the other one is on the way up for productivity. There are facts here. ID increment is a fact, right? So it's way off to the right-hand side of the line. If you consider the human cognitive mechanism, we consume facts fast when we scan by vertical scanning. Horizontal scanning can happen in the F pattern. Those of you who will do UI design and study UI design or human cognition might know what that is. But principally, especially in program code, because we're conditioned to the verticality of code. We put the significant stuff on the left margin. If you don't, you're basically telling your readers to go F themselves. That's a moral failing, not a technical failing. So there are two facts here, at least. One is that we're using the ID.example, and the other one is that the increment of this particular ID is 111. Other controls may be 222. Other controls may be 333, maybe 4444444. Those are differentiators, right? So those are the differences, the subtle differences that you want to basically, I'm going to use the term call out, but what I mean is accentuate. Call out I'm using just because it's common terminology, but you need to accentuate, you need to draw attention to these things. Understanding what to draw attention to understanding what the locus of attention is, i.e. where attention falls, understanding how human cognition works, that's how we optimize our code so that it can be absorbed by glancing at it rather than wrestling with it. So why do you do this? Because you care about people. Why would you not do this? Because you care about getting out of your job early or going home or whatever. It's about self or others in the end. It's about understanding what is significant in any artifact you create, whether it's a code file, whether it's a user interface, whether it's a tweet, whether it's a document, whether it's a book. It's all about making that extra effort, agonizing over illuminating what is significant that the reader should know. What are the differentiating factors in this bit of code? So secondly, you may have methods like in an entity control, for example, that you might have every attribute might have its own method. That's because those things may actually be used by other controls. So you got two purposes, but they're all about composition, and composition is all about knowledge acquisition. That's the story.
That's awesome. Thanks, guys. I don't know why, but the monitor in the room here
Yeah.
has frozen
Ah, there
with
we go.
portrait superimposed on it.
Oh, I was seeing, yeah. Had Scott's face in the middle of my face.
Cool.
Can you describe a little bit, I assume you work at an organization or have worked, where these controls are actually used for sales demos, because you put it on your list. That level of collaboration and coordination is mystifying and amazing to me right now. Can you describe that a little bit?
Yeah, so we have I'll try to describe. We have UI controls, and so we have people that do sales demos, and they use the UI controls that we have in order to set themselves up for the sales demos effectively. And it's a web application. So when I say UI, it's a web UI.
That would be beautiful.
Yeah, super useful.
One of the difficult things with controls, I think, not like understanding how to write them or whatever, but suppose you're trying to influence other people that you work with to use them. Like if you're bought into the idea, you can see how it helps you in your work. It makes sense. But for me, like a huge shock was like, what does a system look like when controls have been used all throughout it?
Yeah.
And you sit down to work in this system and it's like, holy cow, like everything I need is just like right there on the shelf. Grab it, compose it together as I need to keep the work moving well. And it's just like, conceptually, you get it, you imagine that world, and then you see that world. But for someone who isn't necessarily bought into the idea and is resisting everything, they never get the chance to see what it looks like when it all comes together. It's game
Some of
changing.
the messes that come from accounts, customer accounts that are actually corporate accounts for doing sales demos with people wanting specific data to be loaded in there. And it's just, wow, for those nightmares to go away.
What if they could have the tools to just set it
Yes.
up however they want? Yeah.
It would be amazing.
One of the signs of an engineering culture that, well, first of all, I mean, gotta understand my expectations have been set very high. So when I speak about pass and fail, they're coming from that perspective. But one of the things that I look for an organization, an engineering organization, and I'm talking about like, if I measure engineering organizations from the lowest in the universe to the highest in the universe, and I look at what's in the middle, I consider that, you know, just if you think of it through statistical terminology, that's the average, the median, the mean. The other English term there is mediocre. Achieving what everybody else is achieving is not very hard at all. And in fact, it takes no effort whatsoever. Doing work and making no effort whatsoever is kind of a shocking, like to me, for me, that's a shocking declaration about how I would live my life. I would consider that a human transmigration that is perhaps not as worthy as it should be. So I would consider one of the signs of a failing engineering organization, and all that means to me is no longer capable of accelerating, constantly under the pressure of deceleration, constantly responding to growth with hiring rather than having the ability to increase capacity. One of those signs is that testing is done with a, here's the term, we've all heard it, quote, snapshot of production data. When you're there, you've lost. It doesn't mean you're dead, doesn't mean you're going out of business. It just means you're not going to get better than that. It means you've achieved a level. And that's what I think of as failure. And that for me comes from the Toyota, the Toyota traditions and Edwards Deming's traditions, and the things that feed the ideas in lean. Things are always going to be getting harder. You're always going to be having more software. You're always going to be having more complexity. The hill is always getting steeper. The only thing you can do to continue keeping pace is to accelerate, because the hill is always getting steeper. You have to keep going faster. When I see this kind of thing where testing is done with the, quote, dreaded snapshot of production data, that's a team that's lost control of its systems or never had control of its systems, because that's not controlled data. That's literally a declaration, like that's a declaration of surrender to the forces of entropy. The only thing you get productivity from, well, two things, clarity and control, but control is a form of clarity. So yeah, when I need a sales demo, a sales data set, I have code that creates it. When I dirty that thing up, I can recreate it in an instant. We can recreate those data sets from a web browser. We don't even, like, that's the thing, like Antoine was talking about, control at the level of observation. If I'm observing, i.e. testing, if I'm making observations in a web browser, a darnware sure as heck I'm not gonna set up state or database state using a terminal window, because that's not the same, that's not the level of observation. You create these tools, you create these capabilities. I create the ability to control my system state at the level of observation. Why? Because the only people who would think that software testing is done by controlling state at a database terminal are developers. They haven't given consideration to testers. And that's effectively another one of those moral failings. That's a self-indulgence problem. Software testers are not going to monkey around with your Rails console. And to require them to do so is a failure. Product managers are not going to monkey around with your Rails console, and to think about them doing so, to have never even thought that they wouldn't want to do that, is a failure. To provide the tooling in the web browser with a click, with a GET request to set up state in databases, in adjacent systems, in integrated systems, that's controlling at the level of observation. And you do that, you keep to that, because that's the apex of performance. in an organization that's creating software that can be proven. And the only reason why software organizations or software developers slow down rather than speed up is because they've made it harder and harder and harder and harder to prove that the changes they've made do what they think they're supposed to do. That's the only thing. If you look at everything that you've done to lose productivity over your current project, your entire job, your entire career, you'll find that commonality. You slow down, you lose continuity because you can't prove what you've done. If you can tune that, control it, then you can control the productivity loss. You can also control your company's headcount size. You can do amazing things with the same amount of people because the people keep getting faster, or at least instead of getting faster, they're at least not losing pace, or at least not losing momentum. By the way, that's what test-driven development is. Like it's a staggering, astonishing thing to see people poo-pooing test-driven development in the last 10 years. I've never seen anybody who was an opponent of test-driven development who could demonstrate test-driven development. Those two things don't exist in the same human being. Once you've grokked that, once you've understood how you connect productivity and the process and the whole thing, and control systems, and once you start studying industry, not just from a software perspective, and once you start studying software, not just from a programmer's narrow perspective, and understand or go work as a tester and study testing, read James Bach, read Kem Kainer, read Brett Petticord, care about the stuff, you'll see a lot of common threads, bright shining common threads that direct you how and where to go. And it all leads back to control. And with that, I'll be signing CDs in the lobby.
I'll take one.
Thank you for the indulgence.
The code examples tonight, obviously we're in Ruby and everyone here is either currently or has worked with Ruby. But when I was at Berkadia and we were largely cargo culting a lot of what Eventide is, we used the same sort of a pattern in our JavaScript code. Just did it by like having an object, and then where you had module in the Ruby code, we had a property in the JavaScript object and same levels of nesting. It helped. So this was not a Ruby talk, although the examples were provided in Ruby. A number of the presentations we've had here at the meetup have been specific. I don't know if we've had anything that was specific to Eventide. It's just we have implemented everything with Eventide, and last week's didn't involve Eventide at all. It's like from ideas learned from Eventide, obviously, but we didn't use the tooling. But this notion of controls is not a language specific thing. So if, for example, you find yourself in a situation where you're about to embark on a great JavaScript journey, this methodology 100% can be used there.
Trying. It's a little painful.
Yeah. Hypothetically speaking, this is all just imaginary stuff.
Oh, it's supposed to be painful.
Yeah.
It's like exercise, as you age. If you don't keep up, if you don't have a countermeasure to the decline, then the decline is going to win. It's going to be hard and harder and harder and harder. But that's how we maintain our sanity. That's how we don't just throw our hands up in the air and give up and say this is like that whole thing where people say oh, software just gets worse over time. There's nothing you can do about it. It's the nature of software. It absolutely isn't. Like software is the only thing that human beings create that we believe the more effort you invest in it, the worse it's supposed to become. Like that's an absurdity, but we literally let ourselves believe that because we haven't found that we can do any better. And it's usually because we're just not studying this as an industry, as a science yet, generally in the developer population. Like it's still largely like software development is, for all intents and purposes, if you break it down, if you gave it to like a machine learning algorithm and had them like compare these things as abstractions, software development in a business and in a business environment right now has very little difference from any blue collar job. It's just happening in a white collar environment. But most software development is done at the same level that ditch digging is done. We can do a whole hell of a lot better. But I would say that only starts happening, when software developers stop referring them to themselves as engineers. Because there'd be a whole lot of awful ditches if ditch diggers were overstating their value by calling themselves engineers or ditch architects. So there's a whole science to software design. Actually, software design is the science of software development. The rest of it is process, and that can be learned from Toyota and from Deming, not from Scrum. And all you're going to learn if you do the study, if you do the work, you're going to see it all come down to proof. You're going to see it all come down to verification. Because that's the special sauce. This is part of it, and it's hard. And by the way, controls, like Antoine said, have to be treated with the same amount of care that you would treat any other code in your system. These are public interfaces. These are tools you're creating for yourself and for your teammates. You have to respect and really love the people you work with to not kind of like give them garbage to work with. And that takes care. You're designing an interface. These are code interfaces. These are user interfaces. And it gets complicated over time. The requirements of your systems change. The controls change. They've got there's maintenance cost associated with controls. You've got to invest that. You've got to make that investment in controls. There is a cost associated with it, because that's the rocket engine that allows you to continue going faster while the hill keeps getting steeper. You can't sort of just write some controls and say, okay, that's done. That's quote just testing. The testing is the only thing keeping you going fast, and the controls are the only thing keeping the testing going fast. And you can't have good, predictable, easy to understand tests when all of your tests are running against snapshots of production data, because the inputs vary all the time. That doesn't really mean you're doing test automation. It means you're doing interactive testing, which is still good, still important. Test automation doesn't mean you stop doing interactive testing, or what developers call manual testing, because it's got some stigma associated with it. But one form of testing isn't sufficient.
Worth calling out, there is also cost associated with setting up the automatic replication pipelines that bring your production database down. And then woe unto you if you improperly anonymize said data and a customer finds out about it, and then you get sued.
It's like stealing.
Yeah.
Yeah.
So you can pay a controllable cost up front, and as you go along, that you can budget appropriately, or you can roll the dice and see how it goes with bringing your production databases into your development process.
The destruction of your business.
Yeah.
Can't remember where I was reading this, but there's this thing. It's like, if you want to do yourself, like personally, the best, like for the future, don't say, we'll fix this in the future, or future me, this is a future problem. But like, tell yourself that future you needs you to do this now. Like, your health in the future depends on you today eating well and exercising, not tomorrow eventually doing it. And so never say that when we've reached the scale where we're big enough that we'll need to have a production database clone, or we'll need to look for alternatives that will have the manpower to do it. Tell yourself that tomorrow and the fate of your company depends on you taking the time to do the hard thing now.
Because by then you've slowed down to the point that you don't have the capacity to fix it.
And adding more heads just adds more people that are confused with the design choices.
Scott used the language of empathy to describe taking all these actions, and what you're saying, I've heard that a lot of like procrastination is rooted in a lack of empathy for your future self.
Yeah, exactly.
Is there a manager in the room? Is Nadeem the manager?
The team is working elsewhere.
Oh, I'm wondering, like, I just sort of realized if there's a manager in the room, who's probably feeling a little nervous by now.
Actually, I'm not. I'm absorbing this and seeing how I can make improvements.
That's awesome. That's awesome. If I made it uncomfortable, I sincerely apologize. That's
No, you didn't. I was wondering if you had a book.
oh yeah.
That's right. You'll be in the
I've
lobby.
been asked that. I've been asked that many times. And you know that books are things that independently wealthy people can produce. Oh, sorry. And Ethan.
And Scott, since you were describing the mediocre, you may pick any one of several million companies in America to have been referring to. So
Oh yeah.
there was no finger pointing.
My people always like I'm unabashedly a student of Toyota, Deming, and Lean. I was a very early mover and somewhat, I guess, pioneering in that sense in Agile in the early 2000s until I started seeing the early failures and started looking for answers. And I found those answers in studying Toyota. And I don't mean reading one book. Like I've talked to people at business school, like, oh yeah, we had one book on Toyota in our business. It's like, no, like I've probably read a couple dozen books on Toyota and tons more on surrounding material. There isn't a way to study this subject where you read a book or read two books. This is a university in and of itself. You'll just well, I don't want to beat this one to death, but it'll change your perspective on what you can achieve in a business. And it's so painfully obvious in retrospect when you see what the answers are and why Toyota beat the entire of Western business by doing things the way they did. But my favorite thing about Toyota is that in the United States, in the 2008 financial crisis, there were two companies that didn't require bailouts. Two onshore automotive manufacturers that didn't require bailouts. One of them was Toyota, who didn't even let anybody go during that time because they didn't have to, because they had resources. And the other one was Ford, who was a company taught by Bill Schirkenbach, who was Edwards Deming's protege, and Edwards Deming is the primary teacher of Lean to Toyota. So I love getting this. Well, it's not really relevant anymore. Like, this is changing and that is changing. It's never changed. Doing things right, going it's expression, going slow to go fast. That's not for the faint of heart. You can't flinch. But it works, and it works every damn time as long as you understand design. Going slow to go fast and not actually understanding how to do things is just a way to burn all of your company's money. So make a study of this stuff if you can, and I know you can. I'm hoping for a fundamental paradigm shift in software development from the age we're in now, which I think of as kind of just like the age of the dark ages of pseudoscience, to an age of science. And the body of knowledge isn't really that massive. It's not like we're having to learn modern medicine. There's a handful of really important concepts to pick up on. And once you grasp them and once you get them, the entirety of the stupidity of what we do regularly in software development will reveal itself. And I'm not talking about mysticism because that's not my thing. I'm just talking straight up geometry, physics.
We got a page to like the Eventide docs of just books that we should read.
I wish. No, I mean, it's, yeah, yeah. No, one day. one day.
You do have on one of your older blogs, list of
Uh,
books that are
That's
influential.
probably 15 years old.
But I remember the titles would stand the test of time. The Goal was one of
Lean,
them.
lean reading list. Yeah, it was about a couple years into the journey, I think. I think if you search Bellware lean reading list, you might find that. Actually, no, that blog has been, oh no, that blog is still up somewhere. I think it's on Google. But yeah, it's way out of date and, you know, represents the musings of someone halfway through the journey. But yeah, it might stand the test of time.
Any other thoughts or questions?
Well, a big thank you, because coming to this series of meetups continuously radically shifts the way I work. And it's hard, but it's worth it. It always pays off. So thank you, Antoine, for today. And thanks, Scott, you as well.
Thank you.
Thank you.
That's great to hear.
And my apologies for being long-winded. I don't know how to be short-winded.
No,
We'll work on it.
your thoughts are very welcome and appreciated, Scott.
Cheers.
Awesome. Thanks, everyone. As Antoine mentioned, Casey here comes putting you on the spot, but we're anticipating that Casey will take the foundation that Antoine laid here and apply it to that more specific use case of UI controls. So I'm looking forward to that as well.
That's cool.
Yeah.
I am very much a student of this right now, and so I will be doing my best to let you know what I have learned so far.
When you
Are you
start
gonna
up-
build, are you gonna build like a sample app to show that with?
That is my intention, yes.
Wow, that's yeah, that's impressive.
Well,
Casey.
hopefully.
What you said there, Casey, when you start a meetup group, meetup prompts you to give the noun that you use to refer to the people attending your meetup. And this one, we're all called learners. If you go to meetup, it'll say like X learners coming to the meetup, because that is our spirit here. That's what we're after doing, is learning more and getting better. We haven't arrived. We never will. We'll just keep making progress.
Can you can we, I mean, it might be a little bit late. Can we mention the summit? Because we missed it last month.
Please do.
There is an in-person 3-day summit for Eventide happening on Vancouver Island. It's quite small. It's very much focused on Eventide Gen 3, so it's not really this kind of learning thing, but anybody who's interested, we might have told you about this last month if it hadn't slipped our minds. So now you have a week, because it starts on September 5th, I believe. So if it's interesting to you, then all you have to do is find an airline ticket that's not gonna bankrupt you in the next to get a flight next week. Otherwise, but
if you're
you know,
local to here, my car still has a couple seats unoccupied in it.
oh, cool.
Yeah, we're driving up.
Go with Ethan. That sounds like a prayer. Go with Ethan.
That's a long drive.
It is. But it's better than flying when you're tall and have bad knees.
Oh.
So yeah, anybody who's interested. What is the discount code? Crap. There's a price when you press the get your ticket thing, but it's make it. Is there dashes? Does
Make
anyone
it-
remember?
Oh, I don't know. But that
It's
should-
make it free, but I don't know if there's dashes in it or not. It's not, there's a price on it, but just if you use the discount code, it nullifies the price. It's not intended to be pricey. It's not intended to have a price. It's intended to cost nothing. And the discount code it's make
it free.
Is there
Yep.
dashes?
Yes.
Make it free will reduce the price to 0. So if anybody's carpooling with Ethan, one, I look forward to the live blogging of that journey. And two, use the discount code. And if you don't remember it, reach out to anybody in the community and we'll find it. There's a summit channel on the Eventide blog, and I'm sure Ethan can point you to all the information you need. And reach out to me as well if you are actually going to come. If you need any help with any of the arrangements and making it happen and all those things.
The CAD to USD exchange rate benefits you if you primarily transact in dollars.
We're I think it's a 20% advantage.
It was 1 Canadian dollar to 0.74 US when I booked. So a little better than
That's
20
pretty nice.
for the number that describes it. I don't have to go about 25. It was 26.
This summit, just to say, is focused on Eventide Gen 3 or version 3, the third generation of the product. We're going to be basically talking about what's going into it, what the work items are going to be, and helping everybody who wants to become an open source contributor learn how to do that and work with people who do in fact make commits to Eventide. So it's kind of like a little bit of a health retreat, sort of. Because of the location of the locale. Well, it is for me because we're from the desert. I look at it as a health retreat. I think of any place that's raining is healthy. So I've got maybe a twisted view of this. So there's a little bit of that and learning about version 3, learning about what the results of the Eventide community survey were or are that we did last year, and basically kind of like an open source new contributor boot camp to create new contributors. So be super cool to have new people trying to help out at any level, from the teeniest, tiniest issues to even the big stuff. So I guess Ethan's local. You can ping Ethan about details about that.
Cool.
Thank you for.
If we have a little time left over, I've got a kind of a fun / scary thing to show.
Oh God, no! Is it the artificial intelligence?
Yeah. If anybody wants to see it.
Fun and scary that Halloween
Wait,
already.
now your face is superimposed on Antoine's eye.
That'll teach you.
Is that-
That was it. That was the fun / scary thing.
That's artificial intelligence.
Anyway, I didn't quite get a picture of it.
So I've been playing a little bit with the Open AI API, trying to see if I could get it to write to, I don't know, make changes to an Eventide component. So I've built sort of an agent of sorts, ultimately giving it the command or the prompt, add a command called suspend, an event called suspended, and a handler that writes a suspended event unless the account is already suspended. So this is a modification to the existing account component. Now, fair warning, this whole thing doesn't work very well. Some parts work really well, other parts don't. It doesn't do a very good job of modifying files. It likes to blow away the contents of files and it modifies them. But the overall premise is has been interesting. So I run it and give it both a system prompt, which kind of dispositions it to be a senior developer that also is new to the team. And I give it several functions it can use to to interact with its teacher, which is me, including asking questions. So in this case, after the prompt, it asked me 3 questions. What are the established norms for writing tests for a handler? What specific attributes do the suspend command, suspended event, and handler have? Are there any existing commands, events, or handlers that are similar to the ones I need to create so I can use them as a reference? In order to save myself some typing, anytime I answer one of its questions, I also store that answer in a vector database, and then take its question and look up similar questions. So this question is, I think, basically identical. So I'm going to go ahead and use this answer. So the next question, it's asked this one before, so I'm going to use this answer. I say suspend should have account ID reason and time. Suspended should have the same. Handlers do not have attributes. Then it asks if there are any existing commands, events, or handlers. And I say to use the examples function. So I also gave it a function it can use to ask for examples of things. So I'll say yes. I'll send those answers to it. Let's see what it says next. So next it asks for examples on the subjects of suspend, suspended, and handler. So suspend and suspended is kind of cheating because that's what I asked it to write. So I'm not going to give it an example for that. I'm not going to give it an example for suspended. But for handler, I've got an example of that, and I just gave it I give it the commands handler for account component. So send that down, and then it asks me for a list of all the files in the project. So one of the functions I gave it is list all the files. So I send it those. Then it wants to read some of those files. So it chose to read the deposit command. It's probably looking for an example of a command. And now that it has the directory tree, it can kind of figure that out on its own. Now it's asking for an example of now it's asking for an event. So it's reading the deposited event. It looks like it just asked for the commands transactions handler. So that's a different handler. So now it wants to write a file. So it wrote messages command suspend. So this is in the right place. It has the attributes I wanted. It looks perfect. So I can actually see that over here in the account component. Then it's writing the suspended event. Same deal. It included a process time, which isn't an attribute I asked for, but it did see that on other events, so it must have assumed I wanted it. It also included a sequence, which obviously isn't something I asked for, and we may never need, because I don't know if we're doing sequential idempotence for this or not. So now we wait. So now it actually wrote a separate file for suspend. That's a handler, which isn't what the rest of the project is doing. Sometimes it modifies the commands.rb file. Sometimes it modifies it and blows them away. Sometimes it modifies it and adds it to the end. It just kind of depends on what it feels like doing. But it does look like it's more or less right. It checks the predicate here, which obviously doesn't exist yet. Does a follow, writes the message, etc. So we keep going. And again, I can kind of follow along here. So now it's starting to do a behavior that I've been trying very hard to get it to stop doing, which is writing a file before it knows what's in it. So it is writing to the load file, which I've instructed it how to do, but it's blowing away the content. So I tell it, this file hasn't been read, read it first, apply changes to it, then invoke update file again. So let's see if it does that. So now it reads it. And now it looks like it added suspend, the command, and suspended in the events, and suspend here. So this commands file, it didn't actually write, so that's kind of interesting, but that's the client object, I believe. but it did add those. I also gave it the ability to run tests. So it can, if it writes a test, it can also run that test. So far, it hasn't successfully run a test. And as a matter of fact, running tests uses up quite a few tokens. So, so now it's written a test. Let's see if it reads it or runs it afterwards. Let's see what it does. And I believe this test, usually when I've seen it, it ends up being not bad. It's very similar to other tests. It uses controls that don't exist. So like, you know, I think it would need to be instructed to create the controls or need to discover it from the runs of the tests that the controls need to exist. But so yeah, so now it ran the test and it says cannot load such file, account component command suspend. Let's see what it does with that. And then it attempted to run the other test and got the same error. And now it's attempting to, looks like, just run it over and over again. So it is trying hard, but probably not going to get anywhere past this. Every time I run it, it's a little different. I have it tuned to like reduce randomization, but there's the temperature. But it still is a little different each time. And ultimately, like, there's a lot left to do in order to make this usable. Who knows if it can ever actually be really usable. It's just been an interesting experiment. You kind of run out of tokens eventually pretty quickly. So the first thing we need to do is teach it how to break down tasks, split it into separate tasks, and then
What does that mean to run out of tokens?
So the large language models are only capable of processing text that is so big. And
Okay.
The chat models actually work by taking the entire chat history and processing that. So it's called the context window or what have you. And so if it runs a bunch of tests, like you can actually see here, prompt tokens 5,700. Once that gets up to 8,000, it'll fail and say, like, you know, you can't keep going. So that's gonna keep going and going and going up.
Start forgetting. I mean, you can kind of blow past it. You'll see this online too, but if it'll start forgetting the beginning prompts and then start giving you incorrect answers.
With the API, it works a little different because you control exactly which messages to send it. And so the way it works is you send it the entire collection of messages every time. It actually has no memory. The API doesn't. So if you want to forget things manually, I believe you have to manually forget them. Yeah, but
So this will change the Eventide component generator quite a bit.
This is the result of, you know, a little bit of hacking while I'm sick. So it's kind of interesting to play with. It really seems to benefit from treating it like a junior developer. So like this system prompt here is honestly sort of how I talk to new team members when they join our team. You know, you're an expert, I get that, but you're unfamiliar. And you know, you're going to be working with a bunch of experts. They'll teach you, ask for examples. You know, Antoine talked about exemplars. We try and point to them so that we can reproduce the good code and not the bad. And you know, obviously write and run tests, blah blah blah. But the idea being, you know, you want to specify, you want to set the parameters, and then ChatGPT or the large language models tend to take on the persona that you tell them to take on, which means that they'll ask questions that they wouldn't ask unless you told them to ask questions. They would just, you know, hallucinate an answer or what have you. So,
you know, that's an interesting point. Sorry, not to take away from the AI, but what you just brought up is something that I guess we kind of glossed over and don't really focus on in the like what are controls for and how can you use them. But their role in familiarizing a new team member with the system can't be can't be overstated as well. Because you effectively get, like, you could actually like open up a new project and sort of cruise through the controls directories and see what this project is about and instantiate any exemplar object and take a look at it. So as a learning tool, there's great value there too. I don't think you pointed that out, right, Antoine?
I don't think so. Yeah, that's a good
Yeah.
point.
Yeah, we can add that to the presentation. I think it's just something that we do so naturally that we don't really call it out too often. So Aaron, this is like showing us how we're all going to be replaced by machines.
Or people that
That's-
can do this.
Yeah, no, I know. I'm totally kidding around. It's like, yeah, go to a developer meetup and show everybody at the developer meetup how the developers are going to be replaced by AI.
Well, hopefully I
Like, way to
demonstrated
make
how that's a bit off.
No, yeah, like we're still off the horizon. But I think
Yeah.
the
I mean,
really
give me another
interesting thing
week.
about the interesting thing about what you just said is like the power. There's emerging power in learning how to interact with AIs to get them to do what they do. But you're not just interacting with it. You've also been training this model with examples of code, and you're working with the ChatGPT's API or OpenAI's API, and you're working with a vector database that's storing pre-calculated questions and weights of things. So
Yeah, and I
obviously,
would be careful using the term training because I'm not actually doing any training. Because training has a specific meaning in the world of
okay.
Machine learning. But so I'm not doing any fine tuning or any training of new models and using an existing off the shelf model. I've just in the prompting of it told it that it can ask questions, and these vector databases effectively serve as long-term memory for AIs. So they can you can tell it to ask questions and access this long-term memory, and then you can write code that will provide access to it. So it's almost like training in that like it gives it access to information it wouldn't otherwise have, but it's not neural network training.
Is that still what's like in the realm of prompting then?
Yeah, it's all prompting. Yeah.
Okay.
Yeah.
Fascinating.
So yeah, I mean, you tell one of the part of the prompt is actually which functions and this is an OpenAI specific things. I don't Llama probably doesn't have it. I don't know if Google's one has it or what, but like OpenAI has this notion of functions, and you can specify a schema for those functions that it will invoke, and then you can return things in that schema and describe the schema, and that allows it to sort of work and they have this term agentic of an agent sort of way, and that's sort of what gets you all this power. And the new ChatGPT code interpreter is sort of a lightweight, an off-the-shelf version of it that can run Python and do pretty incredible things like charting and data interpretation, etc. Just off the shelf, just by interacting with it in ChatGPT.
So Scott, we don't have to worry about our jobs until you finish yours, because OpenAI is a language model and it imitates the averages. And as you have pointed out, so the reason
I've made the exact same comment.
He points this OpenAI to well-written software that is literary. So until at the very least people can recognize what literary software looks like, we're all safe.
Yeah, until that point, the A in AI stands for average.
Which is back to our earlier discussion. We need to be.
And that's not much of a threat. That's not much of a threat unless your company and your work environment has been conditioned to see the average as acceptable. But as long as we all start producing at an above average level and set the expectation even higher and not like slowing down our companies by doing that, it'll be hard for AI to catch up. I think we're at least what, Aaron, 2-3 months away?
Yeah, I mean, at least.
Oh my gosh.
You
Folks-
invited the agent to the summit, right? Because
Yeah.
we're not trying to make enemies.
It's gonna be like, it's like, was it 1980s? Like,
Oh, boy.
I'll add a purchase plane ticket function to the.
That's why Ethan's driving.
Max Headroom. I'm trying to remember Max Headroom, who was on like MTV or something. He was like an,
Yeah,
like a,
you're dating yourself there. I mean, I know what you're talking about, so I'm dating myself, but.
It was awesome.
we're two lonely people dating themselves. That's quite the statement of where our lives have ended up.
Yeah, indeed.
Gentlemen and ladies, thank you for a wonderful evening. I gotta bounce.
Yeah, thanks for indulging my impromptu demo.
Red, thanks for having it. Thanks, Antoine, again. Thanks, Scott, and everybody. And as always, we'll get this posted up to the YouTube channel at some point in the future. We're getting out kind of
Oh,
early.
this is recorded? I always forget these are recorded. God damn.
Okay. In all seriousness, I can cut things out about anything. So
Use your best judgment.
I did not hear anything that was like, that better not get out. So.
All
No,
right, that's great.
Just kidding. The only time we have had to cut something from the meetup recording was when we got Zoom bombed.
Oh yeah, fun times.
Still don't like, yeah, anyway. Okay, have a great night, everybody. Thanks for coming.
Good night, everyone.
Yeah.
Thank you. Have a good